So my name is Sia. I have done this talk 4 times before, but the last times I've done this one, Azure Functions was at a different state. A lot of things that are in now wasn't there now, so I had to update it. The good thing is my presentations are all on GitHub, so the old version is still there if you want to look it up, but this is a new one. I promised to bring something with Fable in it, so I have this. It is FableConf. This is all I have about Fable, so I hope this is okay. One thing to mention, this is important. So last time I was giving, or one time I was giving this talk, someone wrote a review afterwards, and he was like, "Oh, I didn't expect it to be a technical deep dive." So this is a technical deep dive. So if you're expecting something else, you should probably change it to the other track. So yeah, what are we going to talk about, or what I'm going to show is, first of all, so what is the differences? What is the history of Azure Functions? What is going to be there in the future? Since we don't have so much time, I will skip some demo parts and get to the core demo part somewhere in between. Most importantly, I will talk about debugging functions. If you have been in the session before this one, Yannick showed how to debug a function. What I'm going to show is how to debug the host. So if there's something down beneath that I need to find out what is happening there, how can I do it myself? Unfortunately, for this conference, the whole host code is written in C#, not in F#. So that's could be a good task for someone if you want to update it. Anyway, so let's go ahead and talk about it. So there were a few different versions of Azure Functions. So there was, at some point, there was a V1. And then there was a V1 Plus, and then a V2, and a V2 Plus. Just so you get an idea how this started. There was a guy who didn't work at Microsoft. He wanted to use web jobs for doing something serverless. But he was a Node.js JavaScript developer. So he was trying to get JavaScript running on web jobs. And this is how it all started with functions. This actually became functions. So Microsoft went ahead and eventually hired this guy. His name is Chris. Nowadays, Chris doesn't work in the functions team anymore. He switched to the Cosmos DB team. But he's a great guy, and he started all of this. Yeah, let's talk about V1. So with V1, we had a lot of different language supports. C#, JavaScript, TypeScript, F#. There was also support for Python, which was experimental, support for Bash scripts, support for PowerShell scripts, and so on and so forth. And we had some predefined bindings, Azure Storage, Event Hubs, Event Grid, and so on and so forth, predefined triggers. The function host was on Azure, running on Azure, or is still. But the functions were all run in process. So it was actually there's an IIS which is running the function host, and within the IIS for each invocation call a new task is created, right? And we had to use Kudu to deploy. What was bad? Okay, we could argue about the first point. It's like it used the full .NET framework, which has pros and cons. One of the problems is the app domain in the full .NET framework, and this was causing a lot of problems. One of them is the Steffen issue, right? If you haven't heard about the Steffen issue, just go onto GitHub, look where Steffen posted most of his issues in the functions repo, and you will see they're all about binding redirects. So one of the biggest problems there is binding redirects. Another problem was because of this issue with the binding redirects and because of the app domain, we were really limited to what assemblies we can use, especially in which version, right? Another bad thing was dev tools weren't good enough. If anyone tried in V1, back in V1, trying to use the new Azure Function Dev tools, they became frustrated very fast. And then with V1 Plus, we got two nice things. One is run in zip. Has anyone heard about run in zip deployment on Azure Functions and tried it?
Non-functions.
Non-function, okay. So what it is instead of posting all your files into functions, you put them all into a zip file, upload your zip file to a blob storage, and then tell functions to use that zip file. They're not going to extract the zip file, they're going to mount it. So it's going to be mounted and run out of the zip, right? Which works pretty cool, pretty good, especially when it comes to scaling, because then you just have to copy that zip file instead of copying a lot of small files like some NuGet packages or npm packages, so on and so forth. And another thing that we got was the HTTP scaling v2. I don't know if you are aware of how scaling works in Azure Functions, especially on the consumption plan. There's a big problem when it comes to HTTP. Talking about scaling with queues is pretty simple. You can peek into a queue and see how many messages are there, and based on that you can scale. With HTTP, the problem is you don't know how many more calls are going to come, right? It could be a special day, you have a sales out, a lot of people go into the website, click it, and you can have millions, but you can't see it ahead. So therefore, what they did with the scale v2 was, hey, you know what? It's going to cost us a fortune, but we'll do it so people stop complaining about it. Whenever one HTTP call is coming in, they're now scaling up to 100 instances already. So when more is coming, they are hot and there to handle the requests. This is what they did in scale v2. And this is how it is today too. So there is no better way. I'll talk about how we could improve this, but this is something that I came up with. I talked to the functions team about it, and it would take some time to get there because it's very complicated. Anyway, so after that we had functions v2, or the preview of v2. It had some nice features. .NET Core, we could finally use .NET Core, which means no app domain. We could sideload some assemblies. Oh yeah, I forgot, the Steffen issue is still there in v1 Plus, right? So in v2, the Steffen issue is still there. And I will talk about it, how we can solve the Steffen issue in the future. So we got .NET Core finally, and we got something that is called bring your own binding. This means you can write your own bindings and just bring it into Azure Functions, right? It works even online, not just on your machine. The problem is less supported languages. So with v2, we only had C#, F#, JavaScript, and they started bringing in Java and Go. But a lot of other supported languages were gone. And also were some supported bindings gone. They weren't there anymore. The whole binding thing changed in v2 when it became GA. So nowadays, v2 becoming GA, if I want to bring it in a binding, even one predefined binding, so one created by the Azure Functions team, I have to install the binding. This is the same experience that you have when you come with your own binding. You have to install it. It is going to be downloaded through NuGet, so you have to put it into NuGet, and then it's going to be downloaded from there and then loaded up. But we got a lot of other cool things in v2 GA. So we got out-of-proc workers for JavaScript, Node.js, Java, and Golang. So we have workers that are running out of the process, that aren't anymore tasks, but real processes. And we can scale those much, much better than within one environment. We got Docker support. You asked about Docker before, right? So here's the thing about Docker support. The worker is running in Docker. It is not the host that is running in Docker. And all the binding magic happens in the host. So if you have a service bus trigger or service bus binding, it's fine because it's happening on the host, which is not running in Docker. But the worker is running in Docker. I'll try to get to a more deep dive on that one later on in the slides. When we have time, we'll see.
That makes sense.
Mm-hmm.
Makes sense.
Yeah. So better scaling, we got better scaling. This is the V2 HTTP scaling that I was talking about. We got better performance because we're running it now out of proc. So the most important thing to understand is that since V2 GA, Azure Functions is running on Service Fabric Mesh. If you have heard about Service Fabric Mesh, that's cool. If not, it's comparable to an managed Kubernetes cluster kind of thing. And we have a new host JSON, V2. And it's important if you use V2 that your host JSON has in there V2 or it won't run. Because a few things changed there. Cons, the Stefan issue is still not solved by today. Is it? It's not, right?
Actually, it works.
For some parts, right? For your parts, at least.
I didn't break it anymore.
Okay. But the problem is, it is.
All the issues that I reported are solved. Right?
Yeah.
But the underlying problem is not solved. It's just that they made the most cases go away.
Exactly. So what I tried to do is with the binding redirects, I tried to focus on having as less conflicts as possible and having as less predefined NuGet packages within the host. Right? This is why you have to install extensions and so on and so forth. But the problem still stands, you can't use binding redirects. Right? So, and another thing that came in is, before in V1 we could mix languages within one function app. Now we have to select the language for one function app. So if you want to have mixed languages, you got to go with multiple function apps, which is fine because it doesn't cost anything to have a function app, I think. Another problem is C# and F# workers are still running in process. We'll see why and how. And there were some breaking changes, which is might be a problem if you worked with extensions before a lot, or with bindings before. Okay, what's the future? Hopefully gRPC for all languages. No, this is a goal. So to use gRPC. Oh, does everyone know what gRPC is? Okay, awesome, cool. So gRPC is a protocol by Google. That's why the G is there. It uses protobufs. Everyone knows what protobuf is? Everyone or anyone who doesn't know what? Okay. Protobuf is a very binary format for data exchange. So you have a fixed protocol that tells you, so at the starting point of 0, there comes this data. Starting point of 1, there comes this data, and so on and so forth. And in the end, you have a binary that you can send over HTTP. So gRPC also uses HTTP 2 and zipping and all the good things that we get from the new HTTP 2, and uses the binary data format to send data, which is faster and serialize and deserialize faster than JSON. So hopefully we'll get gRPC for all languages. By using gRPC, what we can do is have all the workers, all the languages run out of process. Because what happens is the host is getting the trigger and then packaging all the data that is necessary into a protobuf and sending it to the worker. This is what happens today in V2 if you use Node.js or Java or Golang. But to a certain point. Right now what they do is on the host side to load everything for the bindings, send it down to the worker. The worker does its stuff and then comes back with the output binding data, and the host is calling the output bindings. Another way to solve this is have worker-side bindings, which means instead of streaming all the data down to the worker, we just send to the worker through the protobuf what binding to use and the configuration, right? So that the worker can itself go and grab the data from the bindings and go and write the data to the bindings. This means, so there are cons to this, this means you have to have the bindings for all the workers. So if you have a blob storage binding, for example, on C# side, you need the same for Node.js, because the Node.js worker has to go to the blob storage and get the data. But this will solve Stefan's issue, finally, because this leads us to bring your own worker. This means I can go and install workers, create my own workers, as long as they respect the protobuf, create my own worker with my own binding redirects, and deploy them to wherever I want. Deploy them to AWS, deploy them to my own Kubernetes clusters, deploy them wherever I want, and then tell the functions host, hey, I am a worker, right? This brings other issues with scaling, like how does the host know how to scale? But there are preparations for this feature in the protobuf already. So the protobuf has a mechanism so that the host tells the worker what capabilities are needed, and the worker can report to the host what capabilities he has, what he can do. This also leads to a more or better way to update workers. So you can create workers of new version that have more capabilities, put them somewhere, and then report to the host, I can do that. So whenever the host is looking for specific capabilities, hey, this worker is feasible for that, he can send it down to that worker. Bring your own trigger is the next point. This is much more complicated, and it will probably take some time to get there. But the idea is that I can write my own trigger. So that I watch onto, let's say, Greg Young's event store, and whenever an event is written onto that, I call a function, right? Run on, we talked about running on everywhere, and there's probably more to come in the future, we'll see. But these things are, or these points are things that I talked to the team about. When Chris was there, he was much more into it, but since Chris left, it's much more talking, and I hope we get there. But if I would have had the time, the whole thing is open source. We'll see that in a minute. So everyone who wants to support those kind of things can get into it. Oh, by the way, if you have questions, just ask right away. Usually at the end of the session, people forget the questions, so. Okay. Yeah.
If I do bring your own trigger and I want you like having where this subpub
pops up.
Same. Then the problem is that where does it run? Because
exactly.
It's not part of the consumption plan to like wait all the time.
No, yeah, but when you look into the triggers, how they work today, let's talk, for example, about the source bus trigger or the event hub trigger, and even the blob storage trigger. What they do is they're running in the host and they're doing polling.
Yeah, but I'm not paying for the time.
Exactly, and this is a whole part where I'm saying bring your own trigger is getting very complicated because you need to install it on the host. The other way would be that you have your own trigger somewhere and it calls the host. So right now, when you look, for example, when you look at the blob storage trigger, not the Q one, but the blob storage trigger, what it does, it pulls files. If there's a file, it puts it into a queue, into a blob storage queue, and from there it's being pulled. So it could be, you could go the same way. You have it somewhere running on your own Docker, whatever. There's a trigger. There's something that is looking up all the time and then putting it into a queue to start right off.
But it's the problem with the pricing, basically.
Exactly.
And don't expect them to like bring your own trigger and then can run arbitrary code and you post on a trigger and they don't pay for it. Then that will be more interesting.
Yeah. Well, let's put it that way. Microsoft has already paid for a lot of things to make it more attractive to the people. So I'm not sure what's going to happen with the pricing. When we talk about pricing, another problem is that the function team has right now. As I told you, it is running on Service Fabric Mesh. Now, problem is, functions team has to pay Service Fabric Mesh team for all the invocations that they use there. So when it comes to the whole pricing part, right now functions is pushed by Microsoft, so they're putting a lot of money in there. And bring your own trigger will be something in the far future, I think. And I hope that it will solve it, because it would be a great feature. But yeah, the problems that you mentioned are definitely there, yeah. Okay, I talked about scaling a bit. I told you how it is scaling. So the next version of scaling could be using machine learning. So what do I mean by that? Is basically looking at your functions and seeing if you have in a specific period, or maybe combined with other metrics. So I'm putting some marketing info out, and I can tell functions that I'm going to expect much higher traffic from that date to that date, right? So it can behave much better. Or looking at, oh, every first of the month there's going to be a high traffic, so maybe I scale at that time much better. This could be a way and to solve the scaling issue that you have with HTTP scaling. By the way, the HTTP scaling problem, AWS has the same problem, and they're also doing mass scaling on the first call, and Google Cloud Functions has the same problem. So they're all having, this is something that is not solvable. Unless you can predict the future, then we should talk. Okay, function source runtime, yeah. So I talked about this a bit, and I will demo this one a bit. It is based on Azure Web Jobs SDK. It is all written in C#, it is open source on GitHub, and it runs locally. Now, let's see how it runs locally. First of all, if you go to GitHub/Azure/Azure Functions, as you can see up there, you will get a list of all the repos that are somehow related to Azure Functions. When you look closely to that list, what you can see is, okay, there's a function host. There's the Web Jobs SDK that it is based off. There are the core tools. These are the some binding tools and command line tools and so on and so forth. There's the Node.js worker, the Java worker, the Python worker. Azure Functions UX. This is the thing that you see in the portal, right? You can go in there and download it. Actually, I don't know if you guys know that, but the Azure Function portal, like this experience, that's Angular, right? But if you look into this guy, I want to show you that for a second. What we can see is like, there's client, which is the Angular part, and there's client React. So they're right now working on a React version of that UI thing.
Will it make the whole portal more usable?
Yeah, more
The question is, are you the right audience for the portal? We'll see. I mean, hey, if it's not usable, there's a freaking GitHub repo. Go on there, fix it, and create a pull request, right?
That's exactly the impression I have, that people are doing that.
Yeah, there are a lot of contributions there, actually, yeah. Anyway, so Azure Function Templates, that GitHub repo is the one where all the templates are. When you go into the portal and you say new function, there are like examples of things that you could do. These are the templates. Or if you in your development environment say new function, these are the templates that are there. Samples are some samples, and VS tooling is well, as it says, it's MS build tasks for building functions. And to be honest, the documentation got much, much better. It's really worth it to look into it. Okay, let's look into code. Yeah?
One question. Short. What?
Yeah.
I don't know if you know it, but there's MS build tasks. Is there any port for the fake building system?
No, but it uses packet, so maybe that's at least something.
They're also using fake.
Hmm?
The team itself is also.
Yeah, the team itself is using fake. Actually, yes.
I think it's packet.
And packet. I'm being recorded. So I have a breakpoint here. Once I'm going to, this is just what, so what I did is basically I loaded up the solution. Wait, let me make it smaller. So I loaded up the solution of the Azure Functions host. And this is what you get there. Just those 5 core projects. And what you have to do, so you have to do some preparation before you can start debugging. So especially for if you want to let because there's a lot of tests, and if you want the tests to be running fine, you have to do some preparation. By preparation, what I mean is you have to set up a few environment variables, right? So you need a cloud storage, you need a Cosmos DB, and so on and so forth. But only if you really want to test this part too. So you need, at least you need the blob storage or some sort of storage account in Azure, where you need to point these to environment vars to. And then you're good to go, right? For the other things, only if you really want to test event hubs and so on and so forth. So before I'm going to start this, I will make the code bigger to F5 it. So when I F5 it, what will happen is the function host will run up, and then it will look into a specific folder for functions, if there are any functions files, right? And what you will see is, when I scroll down here, a lot of things that happen is there's a lot of IL code actually happening here, right? So when they start indexing the functions, there's a lot of IL code running to generate from the different function CSX real compiled things, right? So what you all know is something like that, at least I hope you know that, is here I have a HTTP trigger, run CSX, which I hope will open up, yeah, which has some function code in there. You have seen that, right? Oh, it is still running. So when I now go F5, what will happen is my debugger will break. I would, by the way, start Postman. I hope it will. There we go. And this is happening when he's indexing the functions. So when we look into this function name, this is the HTTP trigger. Is this, can you see that? Probably not. I'm not sure why it's not working with. Anyway, so this is HTTP trigger. So this is the function. He's right now indexing the function. So I can go through that and see what is actually really happening in there. So there's an invoker, and in the invoker we can see there's an input binding. We can look into the input binding, and we can see it is of type. It is the name of the parameter is request, right? It is an indirection. Methods that are allowed is get. So this is all building up from the function JSON that I have. Right? And there might be output bindings. Oh, there is one, an HTTP binding, right? We look into it, we can see this is the return value. So we can see all this happening in the code. And if we go on step by step, we'll see how it is generating IL code to generate whatever is in my function JSON, right? Anyway, we'll skip that. Okay, and once it is done, we'll end up with this page. Your Functions 2.0 app is up and running. So now what I did is I have in my folder where my functions are, there's a host JSON. And in my host JSON, I told him just to index these functions. So I can tell them, hey, just look at these. Don't look at all the others. Because there are some time-triggered functions. And if I start those, I'm not getting out of the debug experience, right? Because it is all the time calling it again. So I just put the HTTP ones in there. And when I now go and look at this one, what I can see is, so there's a HTTP request, there's a log, right? And I want to call this function. So basically what I do is use postman. And one thing that will happen when you start with this is when you call it, it won't work. So to see the URL, probably it is wrong because the port might have changed. No, it's fine. You can see the URL. It's /API/whatever my function is called. This is the same experience that I get when I do it in the portal. So when I call this, he will complain. He will be like, oh, where is the key? You know that. You need a key unless the function is anonymous. To get keys and to understand how the keys work, you can look into the code. Because there is, if you ever have done ASP.NET, MVC, or API, web API, you will know this. So there are controllers, and there's a keys controller, right? This also means that I can call these endpoints, even in Azure. Let's look into the key controller. So what I changed is I took out the authorization part, because I'm running on my local machine, right? I don't care about authorization. It's my own thing. So I took out the authorization part so I can call this controller. And when we look into it, you can see there are endpoints, admin, functions, name, and then keys that will return me all the keys for that function. This also means that when I'm doing DevOps or deployment, I can call these endpoints as long as I have a valid OAuth token to get the things that I need, right? So there's much more. I can even bring in keys. So as you can see, there are HTTP posts where I can post and create keys from out of my DevOps experience. I think this is important to know because this is not very well documented when you look at the functions, right? And I can delete keys. And this is all part of the keys controller. There are more controllers, right? There is also the host controller, which has a few other things. I can ask for the status of the host, right? I can ping the host. I can get the log from the host. The debug part is, I wouldn't use this. It's a bit rough. So it starts a debugger, as you can see here, but only if it's self-hosted. So not if it's in Azure. So in Azure it won't help. It will give you a 501 not implemented. But looking into these kind of things, you can see there are a lot of things that are important to understand. When you look at sync triggers, this is something that is called by the workers. So the workers call on the host sync triggers to sync the triggers with them. Right? You can restart, you can get the state, a lot of things. Another one would be interesting is the extension controller. This is the new one. This is interesting if I want to bring in now my own bindings. Call the extensions controller or the extensions endpoint and give him what needs to go in there. Extension package reference. How does the extension package reference look like? there it is. ID has the NuGet package name and version, the version that you want to have. Just create a JSON, send it there, it will install the extension. Okay, so now let's look into the other part where I'm calling a function. So I got myself the keys by calling the keys endpoint. Probably there's a new key that I need to copy. Oh no, it's still the same. That's good. Just to make sure. Oops. Okay, now we'll call the endpoint, so the function. I prepared this breakpoint. So this is not the earliest point where it's doing something in function. This is actually one of the latest points, right? This is where it's actually invoking my function. And when we look into this and go in there, there's not much happening. So it's calling my function. We can see here in the lambda, here, I'll zoom in a second. Just let me open up the right things for you. Actually, this is not very helpful. Let's go here. Ah, shit, I hate it. Ah. It's not seeable at all. It's too bad. What I can do is take the watch window. Is there a way to zoom in the watch window? I don't think so, right? Okay. So let's look at this part. So what you can see is it says, okay, listen, this is a task that is returning an actual result, right? And when we have a look at our function that we just called, we can see, hey, it's an actual result, right? And when we go on and look not into the lambda, but where is it called stack? Log into the arguments, look into the arguments. What we'll see is there are 3 objects in there. And when we look at them, it's the logger, it's the HTTP request, and then there's the execution context, so the context that the function app is running in. So we can see all our code that we had in the C# here. Yeah. Oh, this is the wrong one, I think. There we go. We can see here there's a HTTP default request and there's a trace the logger, right? So both of the things that we have in our function is actually there and called. And if we go on with the execution, go out, what happens here is the next step that is called is set return value. So now on the way out, he's setting the return value. What I haven't showed you, because we don't have enough time, is when you go to full stack trace, you can see how he's going to the bindings and calling the data that is needed, putting it into the execution, and then on the way out is setting it up for out, for return value. Did you have a question? Sorry. Okay. So after this is all gone, when I go F5, you can see, okay, it's all passed and it's all good. So I just called the function on my own host. This also means if I really want to do it, if I really want to take the time, I can take this code, this host, and put it on somewhere else. On my own Kubernetes, on AWS, whatever. And I get a full Azure Functions environment, more or less. But this is all fine and nice as long as you don't scale. Because the problem is you have to understand how scaling works to do it the right way. So as you can see, there's a project that is called scaling. And when we look into the scaling project, what we will see is a lot of app service something. They know how to scale in Azure. So if you want to put this into your own environment, you got to bring in your own scaling controller. You got to implement your own scaling. But then it's totally fine. Just go ahead. Because they're all using interfaces here. You can just write your own scaling handler, a manager, and do this on your own. Okay, we don't have much time, right? I think I'm over the time. Damn it. Just one last thing that I want to mention. Bring your own binding. So it is completely documented. You can go in there. There's a full document of how to write your own binding. It is pretty cool and is a lot of fun. I wrote the HTTP binding, so I don't have to do HTTP calls. I just give it to that binding. It does the HTTP call on the way out. And you can put your bindings into NuGet so everyone else can consume it too, right? I think there's a better way for doing output bindings. Right now, output bindings suck because they're using out on the C# side, which is even worse on F#. And I think there's a better way to do this by using tuples. But I haven't had the time. This is something that I want to do for over a year. I just don't find the time to do this. There is also great specs and everything on the language extensibility. I wanted to show you the protobuf. We just don't have time. And in my slide, there's also how to get started with debugging. So if you want to take that slide, it's on my GitHub, and then you can just go from there. I will put some more links into the slide, so you can also get to that cool list of all the different things that are involved. Just maybe one quick thing here. Where is it? No, go wrong. Yeah, here. So this is the protobuf, right? If you look into it, there's a lot of things defined, like how to get a status request, how to get a response, worker terminator, and how it all works. You can look it up. It is all in there, and it's also open source, so you can extend it and create a pull request. It's all up to you. If something doesn't work, make it better. Right? It's open source. So probably this is my last slide. It says, thank you.